There's this really exciting new development in the treatment of osteoarthritis, driven by a study in mice from Stanford University that looks at a protein called 15-PGDH.
Yeah,
Essentially, as we age, this protein ramps up and seems to block the molecules that repair the tissue, which, well, makes our joints break down.
right. And that cartilage breakdown is really what causes the pain and limited mobility and osteoarthritis, isn't it?
Exactly. And here's where it gets interesting. By inhibiting 15-PGDH, researchers were able to actually thicken up the worn down cartilage in
Mm-hmm.
old mice. That's like hitting the reset button on joint health.
And what's especially fascinating is that in tests with younger mice who had injured knees, the inhibitor essentially prevented the development of osteoarthritis after injuries.
Right, right. It's like the treatment not only repairs, but also acts like a sort of preventative measure against the kind of damage that leads to arthritis.
Yep.
Plus, they even saw similar regenerative results in human tissue samples from knee replacement surgeries.
That's amazing because current treatment options mostly just manage pain rather than actually fixing the root cause, right?
Exactly. And this approach doesn't even rely on stem cells, which have been the go-to for cartilage repair until now. It's more about transforming the chondrocyte cells in the existing cartilage into a healthier, more robust state. This could
Yeah.
represent a big shift in how we approach joint degeneration.
I do wonder though, isn't there a risk that if we alter the gene expression in these cells, it might have unpredictable side effects in the long run?
That's a fair point, and while the early results are promising, there's still a lot of work to be done in clinical trials to assess long-term safety in humans. But the fact that the
Mm-hmm.
treatment improved the gait in mice and increased their weight-bearing capacity is a solid indication of reduced pain and overall better joint function.
And considering that current options eventually lead to joint replacements, this could be a game changer.
Absolutely. Imagine a future where we can sidestep hip or knee replacements altogether because we can actually regrow and restore our cartilage. It's like moving
Totally.
from patching up an old car to rebuilding it from scratch.
That's a powerful analogy. And the use of a 15-PGDH blocker, which has already been checked for safety in previous muscle weakness trials, really accelerates the potential timeline for human trials, doesn't it?
It sure does. There's enormous clinical promise here, and if further tests hold up, we might be looking at a whole new era in treating not just arthritis, but other age-related joint issues.
Yeah.
However, I still think we need to be cautious and wait for more comprehensive data before getting too excited.
For sure, the cautious approach makes sense. It's exciting, though, because it shifts how we think about aging and joint health.
Exactly, this breakthrough opens doors to rethinking tissue regeneration entirely. And the fact that the existing cellular pool is transformed without needing stem cells challenges some of our previous assumptions about regenerative medicine. It's a bold step
Right.
forward.
So, in essence, by targeting the increased 15-PGDH, we might finally be able to address the underlying causes of osteoarthritis, leading to real improvements in quality of life for seniors in the future.
Precisely. And as the research moves forward, we can only get more excited about the possibilities this holds for millions suffering from joint pain.
Absolutely.